We're now going to evaluate limits at infinity. And before we get into our example problem, we're going to look at a rule that's going to allow us to simplify these types of questions. So here we have our limit as x approaches infinity of some constant over x raised to an exponent, which is going to equal 0. So what this means is that as x approaches infinity, the denominator is going to significantly increase, resulting in a very small number or 0. And we can kind of visualize this if we let x equal 1,000. And if 1,000 was raised to the second power, this would be a very small number or 0. So we'll go ahead and get into our example problem where we have the limit as x approaches infinity of some function. And the trick we're going to use is we want to simplify this function in order to look like our rule. This is going to allow us to evaluate or simplify these types of problems. So the first thing we see is we have x to the fourth in the numerator as well as x to the fourth in the denominator. And so we want to factor that out. So we'll go ahead and do that. We'll factor it out in the numerator and denominator. And what we're left with is terms that are going to look very similar to our rule that we discussed earlier. And so when we evaluate the limit of these terms, we're going to have a solution that's going to be a lot more simple. So we'll go ahead and cancel out the x to the fourth terms. And so what we're left with is the limit as x approaches infinity of our numerator and our denominator. And so now we can go ahead and evaluate the limit. And you can see that our 2 is going to stay the same. 1 over x squared, we can use the rule that we discussed earlier and simplify this to equal 0. And 8 over x cubed, we can do the same thing as x approaches infinity. This is going to be very small, or 0. And so what we're going to have for our numerator term is 2 minus 0 plus 0. And for the denominator, we're going to have negative 5 plus 7 divided by x to the fourth. And when we evaluate our limit, similarly to what we just did, this term is also going to simplify to 0. So now we have something that's very simple. We can go ahead and take our limit, and what we're going to get is negative 2 over 5 for our solution.